Hello, welcome to CREATA CLASSES. I am Gurmeet Singh. In this lecture, we will cover the questions based on surface area and volume of cuboid and cube. Note that this lecture is part of the complete series on surface area and volume of various 3D solids. So let's begin the lecture. The question is, the dimension of a rectangular hall is 10 meter into 15 meter and height is 20 meter. The walls of the room needs repainting. The cost of paint is $10 per meter square. Find the total cost of the paint used. This is the question and we have to find the total cost of the paint used to repainting of the walls of the rectangular hall. So let's observe this question. In this question, a rectangular hall is given and the dimension of this rectangular hall is 10 meter into 15 meter, that is length into width is given, and height of this hall is also given as 20 meter. Rectangular hall means it is a cuboid. We got length as 10 meter, width as 15 meter and height as 20 meter. All the three dimensions of the cuboid are given. Further in the question, it is given that is the repainting of the walls is required. Means we have to consider only the walls. Roof and the floor is not included in the painting of the walls. So only the four wall of this cuboid we have to consider. That is, we have to consider only the lateral surface area. Okay. We need the total cost of the paint. Means we have to calculate the surface area of the wall of the rectangular hall. Means we have to calculate the surface area of this rectangular hall. Okay. We know the formula of lateral surface area of a cuboid, that is twice of L into H plus B into H. Let's put the value. We got lateral surface area as 1000 meter square. We got the total surface area or the lateral surface area as 1000 meter square. And we have to find the total cost of the painting. Cost of the painting is given as $10 per meter square. So total cost will be equal to 10 into 1000. That is $10,000. That is the answer of the question. Okay. Let's move to the next question. The question is the length of the longest rod that can be placed in the room, which is 12 meter long, 9 meter broad and 8 meter high. Okay, 4 choices are given. Pause the video and try to solve the question. Take your own time. Let's approach the question. First of all, let's review the question. The question is talking about a room. The dimension of the room are given as 12 meter, 9 meter and 8 meter, and we have to calculate the length of the longest rod that can be placed in the room. So what will be the longest rod that can be placed in the room? First of all, this room is a cuboid and we have to find the longest rod that this cuboid can accommodate. So what will be this rod? This rod will be the body diagonal of the cuboid. We have seen the longest rod that a cuboid can accommodate is the body diagonal. And we know the formula of the body diagonal as root of L square plus B square plus H square. L, B and H are given. Let's put the value and let's solve it. We got the answer as 17 meter. That is the length of the longest rod this room can accommodate. Okay, got it? Let's move to next question. The question is, the perimeter of a floor of a room is 18 meter. What is the area of the wall of the room if the height of the room is 3 meter? Okay. Pause the video and try to solve the question on your own. Let's approach the question. We will go step by step. Our first step is to observe the question. Let's observe and visualize this question. The question is talking about a room. The perimeter of the floor is given as 18 meter. What is the perimeter? Perimeter is the total length of the boundary of the figure. Here the floor of the room is a rectangle and the perimeter of the rectangle, that is the perimeter of the floor, is given as 18 meter. So if we take the dimension of the floor as L and B, that is length and width, so can we say twice of L plus B will be equal to 18 meter. Further, the height of the room is given as 3 meter. Further, we have to calculate the area of the wall of the room. Here we have to calculate the area of only the walls, means floor and the roof is excluded. Means the question is talking about the lateral surface area. And we know the formula of the lateral surface area as twice of L into H plus B into H. Let's take H as common. We got 2H times L plus B. Okay. Here H is given as 3 and twice of L plus B, that is perimeter, is given as 18. Let's put the value. We got the answer as 54 meters square. That is the area of the wall of this room. Okay. Let's move to the next question. The question is, the volume of a cuboid is twice the volume of a cube. If the dimensions of the cuboid are 9 cm, 8 cm and 6 cm, the total surface area of the cube is, 4 choices are given. Pause the video and try to solve the question. So let's observe the question. This question is talking about a cuboid and a cube, and the volume of the cuboid is given as twice the volume of the cube. And also the dimension of the cuboid are given as 9, 8 and 6 cm. That is L, B and H are given, and we have to find the total surface area of the cube. Okay. So let's approach the question. Firstly, it is given as volume of the cuboid is twice the volume of the cube. And what is the volume of the cuboid? It is length into width into height. Okay. And L, B and H are given. Further, let's assume the side of the cube as A. So we got the volume of the cube as A cube. That is the formula of the volume of the cube. So let's put the value. On solving, we got A as 6 unit. That is 6 cm. Okay, got it? We got the side of the cube. Further, in the question, we have to find the total surface area of the cube. And we know the total surface area of a cube is 6 times A square. And we got the value of A as 6. Let's put the value. We got the answer as 216 centimeter square. Got it? That is the answer of the question. Okay students, got it? We have done with the cuboid and the cube. In the next lecture, we will take the cylinder. So that's for this video. Thank you very much and best of luck for the exam you are preparing for. Note that this is the series on volume and surface area of various 3D solid. So best of luck and have a great day. Bye for now.